Let's dive into self-healing clouds. Subscribe to the channel and like this video for more great cloud tips. Self-healing clouds is on the frontier of cloud operational excellence and site reliability engineering. Self-healing infrastructure means AI agents watch your systems, detect trouble, and repair it without you. They observe health signals, diagnose the cause, and apply a fix. AWS DevOps Agent is one managed shape of that loop. It runs always-on investigation, root cause analysis, and mitigation plans. Those span AWS and multi-cloud signals. Humans still own risky execution in many deployments. Most routine failures get resolved before anyone opens a ticket. Closed-loop automation puts detection and repair inside the same feedback cycle. Traditional monitoring is an open loop. It ends at an alert and waits for a person. A closed loop carries that same signal through diagnosis and into an action. Why does that change your design? Every component now needs a machine-readable health signal and a safe repair path. MTTR reduction follows. Mean time to recovery stops depending on who reads the alert first. Observability-driven agents can only fix what your telemetry actually exposes. They consume metrics, logs, traces, and events. Those come from Prometheus, Amazon CloudWatch, Azure Monitor, or Google Cloud Operations Suite. Telemetry correlation joins a latency spike to the deployment and the node behind it. An agent stitches a trace ID across services to find where the request slowed. Instrument with OpenTelemetry first, since agent quality is caped by signal quality. Let's anomaly detection agents learn what normal looks like for each service. They flag a departure from that baseline instead of firing on a fixed threshold. A model that knows your Tuesday morning shape separates a real regression from a busy hour. What does prediction buy you? Predictive failure detection spots disk wear, memory creep, or certificate expiry days ahead. Replacing a node before it fails costs far less than recovering after it does. Root cause analysis agents answer the question an alert never does, which is why. They pull changelogs, deploy history, service topology, and failing signals into one view. Then they rank hypotheses and test each one against evidence they can query. A good RCA agent tells you the config change that afternoon shrank the connection pool. Suppressing the symptom without RCA moves the outage to next week. Automated remediation is the action half of the loop. Runbook agents take procedures you already wrote and choose which one fits the situation. Typical actions are restarting a pod, rotating a credential, or failing over a replica. LangChain's open autonomous SRE agent for Kubernetes is an example. It uses cheap scheduled health reads, full investigation on demand, and every write tool gated behind human approval. Immutable infrastructure recovery is usually safer than repairing something in place. The agent does not patch a sick instance. It replaces it from a known good image or container digest. Kubernetes, EC2 autoscaling groups, and Azure Virtual Machine scale sets make that replacement cheap. Policy-bounded autonomy defines what an agent may do without asking. You encode those limits as policy. Use Open Policy Agent, #EE Corp Sentinel, or your provider's native guardrails. Operational autonomy levels give you a ladder rather than a switch. The rungs run from suggest only to approve then act to fully autonomous. Move one action up that ladder once its success rate earns the promotion. Human-in-the-loop escalation covers everything above the line, including anything touching stateful data. Production patterns now bake that split into structure, not just prompts. Read tools stay autonomous. Scale, restart, and patch actions live in a separate change executor. That executor sits behind Slack or ticket interrupts. Blast radius limitation keeps a bad automated fix from becoming the incident. Scope each agent to one environment, account, or cluster. Give it credentials that can't reach further. Rate limit the actions themselves, so a remediation loop can't restart every node in the fleet. Canary remediation applies the fix to a small slice first and watches the result. If error rates improve, the agent proceeds. If they don't, it rolls back and escalates. Configuration drift correction handles the slow failure mode, where live state stops matching your committed code. An agent compares live resources against Terraform, Bicep, or Pulumi state, then reverts or files a pull request. Platforms such as Commodore with Claudia and Cast AI agentic operations push the same idea for Kubernetes. They run continuous detect, investigate, remediate, and even cost-aware healing with optional human in the loop. Chaos engineering plus agents is how you find out whether any of this really works. Inject a failure using AWS Fault Injection Service, Azure Chaos Studio, or Litmus, then measure whether the agent noticed and fixed it. Untested remediation is a script you only hope behaves during an outage. Learn more at systemsarchitect.io. Like and subscribe to the channel and follow the playlist. Operations gains the most since repetitive incidents stop reaching your queue. What compounds that gain? Feedback loops and learning, because every resolved incident becomes labeled data for the next one. Agent Ops is the emerging discipline around running these agents. It covers versioned prompts, tracked success rates, and an audit trail. Trace platforms such as Langsmith increasingly close that loop. They cluster related incidents and propose evaluators. Some even open fix pull requests when agent checks themselves regress. Reliability improves because recovery no longer depends on who happens to be available. Costs fall too. Capacity problems get corrected in minutes instead of paid for as permanent headroom. Self-healing is the wrong choice when the failure is genuinely novel. Agents are strong on incidents you've seen before and weak on the ones nobody has. Keep irreversible actions out of scope. That means deleting volumes, dropping tables, and restoring backups over live data. A small app rarely justifies it. The telemetry, policy, and audit layers cost more than the incidents they prevent. Watch for automation that hides a real defect by restarting a leaking service forever. Self-healing clouds close the loop from telemetry to diagnosis to repair, so anomaly detection, RCA, and remediation agents handle routine incidents on their own and cut mean time to recovery. The pattern only stays safe with policy-bounded autonomy. You also need blast radius limits, canary remediation, and human escalation for anything irreversible. Recent field guidance is blunt. Let agents own investigation and safe restarts. Keep stateful or multi-resource rights on an approval rail until success rates earn more autonomy. Adopt it where repeat incidents and drift are eating your week. And keep a human driving novel failures and destructive actions. Thanks for checking out this video. Hope you liked it and subscribe to the channel. Find a lot more articles and guides both on systemsarchitect.io.